Hello everyone, this is a video lecture for Pre-Calculus, section 11.3, Hyperbolas, or Hyperbolas? Hyperbolas. Anyways, let me show you the difference between what's going on. So far we've seen parabolas, we've seen ellipses, and now we're going to see hyperbolas. Okay. They differ in eccentricity from one another, but we're not going to get into all the little technicals. We're just going to say, hyperbolas. Yay, look at that. Let me give you the formulas. X minus h all squared over the major squared. I want major with a capital. Major squared minus y minus k squared over the minor squared equals 1. Or, this is just like last time, y minus k squared all over the major squared. Then minus x minus h squared over the minor squared. Now notice this time it's a little different than the ellipses. We have a minus sign between them. We have a minus sign. The major is always positive. The major is always positive. So remember how I said that that major is the bigger one? So yes, kinda, if you kind of think about it. Assume that we have like a 2 and a 3 here. Just kind of saying, like if we have a 2 here and a 3 there. Well, 2 is smaller. Well, no, it's a positive 2, and we have a negative 3. So which one's bigger is technically positive 2. Wah, wah, wah. It's kind of a joke, but regardless, major's always positive. It's always over on this side over here with the positive side. And so you could have this number here be a smaller number than this guy here, and that's okay. He's still the major. He's still going to determine what it looks like. So in x major, you got x majors along the x-axis, foci and all that kind of stuff. A y major is along the y-axis, again with foci and stuff like that. Let me give you a couple more formulas. So c squared is now equal to major squared plus the minor squared. Last time it was a minus sign for the ellipses. Now it's a plus sign for the hyperbolas. But it's kind of weird because the original formula has a minus sign here, but last time it was a plus sign. So they're kind of flip-flopped on that sign right there. E is still C over major. So that's good. And they have an asymptote formula. I'm going to be showing that to you in a couple minutes. Right now it's not as important to us, at least at the moment. So 11,3,005. I got x squared over 25 minus y squared over 1 is equal to 1. Notice that when I rewrite them as squares, so that's 5 squared, that's 1 squared. Why did I put a 1 up there? I don't know. Okay, anyways. This is definitely the major, not because it's the bigger one, kinda. I mean, it is the bigger one. But because it's the positive one. It's the positive. This is always going to be your minor over on this side. Okay? So you got an x major, a y minor. So I'm going to go out 1, 2, 3, 4, 5 distance. 1, 2, 3, 4, 5 distance for my vertices. Those are my vertices. And you're good to go. Again, I'm thinking about it like positive and negative, and I'm not too concerned about the actual value on the inside. Positive values are always bigger, technically, bigger than negative values. I just don't want you to get confused. So I'm trying to show you all the different tricks and stuff like that. Okay. So we have this new formula here. I, of course, want to get an equals 1 all the time, equals 1. And so here they flip-flop just like you've seen many times before. So it's now a 9. It's now a 4. And so then we got x squared over 3 squared. Again, that's a positive. That's your major. y squared over your 2 squared. That's your minor. So major x at 3. There you go. There's your graph. Notice that I'm not even attempting to graph what the minor would look like with this. How does that 2 relate to that graph? I don't know. It relates. It's just with the asymptotes, which I think actually it's this problem right here that we're going to talk about it. So x squared over just 9, divided by, minus y squared divided by 36 is equal to 1. Notice that whenever I rewrite this, it's positive 3. This would be a 6 squared. Again, this is still your major because it's a positive 3, if you see that, versus a negative 6. Again, that's just visual cues. It's not really a negative 6. It's just the point that I'm trying to make here is that your major is going to be the positive ones, technically bigger, I guess you can say. So I got a major, x major there. And they were going to want a lot more stuff with this particular problem, so let me go and start finding all of the little nitnecky things. So c squared is equal to major squared plus the minor squared. So 3 squared plus the 6 squared. 9 plus 36 equals 45. And so then c is equal to the square root of 45 when you square root both sides there. That's important. Later on, we got E is equal to C over major. And so square root of 45, my major was a 3. That's good enough. So that's my E. Cool, cool. And then finally, they ask about asymptotes. I'm going to compile all this together here in just a second, but we need to talk about asymptotes for a little bit. So this is kind of like a break. My asymptotes have a formula, a very particular formula, y equals mx, basically. Now, that's in theory. What it really is y equals plus or minus mx minus h plus k. That's the real formula. We will be using that again later. But for this section, simply put, it'll be just a plus or minus mx. M, and I've used this little m for minor before. I don't want you to break that. I don't want you to think that right now. That means slope. Actually, that was a really good. Nah, let's get rid of it. It means slope. So I guess in a more Englishy way, y equals my slope times x. There you go. Plus or minus, I suppose, like that. We need to know what the slope is going to be. And I'm going to give you the final definitive version of my asymptotes. If you're ready, here we go. Plus or minus y distance over x distance times x minus h, and then plus the k. That's the definitive version. Again, these are going to be zeros, so it makes it a little bit easier when we're doing it right now. What is x and x distance, y distance? Let me use a different color for this. My y and x distances are the majors and the minors, but appropriately with their coordinates, with their x or y coordinate, I guess you can say. Variable. Maybe that's a better word. Essentially, here's the idea. You can see that I have my two numbers right here, major and minor. Now, notice that this is an x. So that's my x distance. It just happens to be the major in this case. And then my y distance is a 6. So I'm saying here in this particular case, x distance is a 3, and my y distance is a 6, okay? Again, it just so happened that I had an x major. It's not necessarily the major minor. It just, what it is the x and the y, okay? Because if you go down and you think about it, this is supposed to be a slope, isn't it? And what is slope? Little m. Again, I don't want to use that in this section, but y2 minus y1 over x2 minus x1. Look, it's the y's divided by the x's. Okay? That's what I'm trying to get at. Y over x. It's like tangent all over again. Tangent theta. Remember, that's like from way back a couple sections ago. They're all tying in together. And so for my answer here, I'm going to say plus or minus, and then I'm going to go back and say what's my y and x distances. Y distance is a 6, x distance is a 3, so 6 over 3. That's my slope. And then x minus 0, or plus 0, I think, technically. Blah, blah, blah. We don't need to really zeros in there. And this is just going to be a 2, so plus or minus 2x. This is my asymptotes. So how do asymptotes work with a hyperbola? Notice again, this is an x major. So I'm going to put my little asymptotes here, this way. And x major is something kind of like this. Let me draw it properly. What a hyperbola actually does, it's not a parabola shape. It actually rides along the asymptote. So it gets closer and closer to the asymptote as it keeps going. So it's not exactly a parabola shape. It kind of looks like that from like this area, but eventually it kind of just hits a straight line almost. So those are hyperbolas. These are the asymptotes that they ride along as they keep going out towards infinity. Cool. Back to the question, because we need to fill in a lot of stuff here. The center is at 0, 0. And remember that we have an x major, so we're going to have to leave a little bit of gap there. Vertices. Remember, this is always driven by the majors. Always. Always driven by the majors. And I had a major distance here of 3, so plus or minus 3. My foci. Remember that it's the formula along my majors plus or minus c. And c is the square root of 45 in this case. And then my asymptotes, they want you to write it out. Plus or minus 2x, which we had just found. Now, this is not exactly what WebAssign wants. They want y equals 2x, y equals a negative 2x. That's what they really want. I'm going to put plus and minus just because it's quicker, but you get the idea. If they accept a plus minus somehow, that would be awesome. I don't really know. And then they're asking for this transverse axis. Like, what is this thing? Well, it's just 2 times the major again. 2 times the major. So 2 times 3 is a 6. And there you go. Whew. 113013. Positive y squared minus x squared over 25 is equal to 1. Now, they didn't put a positive there, but I'm showing you because I want to make sure that you see that this is the major. Major with a capital M. And it's a y major, so that's cool. We haven't seen one of those yet. This is a 5 squared. That's a minor. Because, again, this is a positive versus a negative. Which one's bigger? Bigger as in, like, more positive. You get the idea. I don't want to always stress that, though. I just want to make a point. And so I have my major. I have my minor. Let's go and find all the other things that I'm going to need before I keep going. So c squared is equal to major squared plus the minor squared. So I got a 1 squared plus 5 squared. 26. So c is equal to the square root of 26. So that's cool. E is equal to c over major. So I got the square root of 26 over 1, right? So that's good. Actually, you know, I'm looking at my notes. I don't think they actually ask for this E very often. Oh, well, whatever. It's cool. We found it. And then the asymptotes. So before we keep moving, I want to find the asymptotes. If you remember how this works, it's y is equal to plus or minus a y distance divided by the x distance. Again, this is major minor. I don't want to say major over minor or minor over major because I don't really know which one it's going to be. I just know it's y over x, and then times x in this particular case. So this is a y distance, and that's my x distance. So a 1 and a 5. So I'm going to have a 1 over a 5. That's it. So that's important there too. So good. Everything's good. So here we go. Center. Again, they might not ask for it yet, but still important to do. Notice that I'm going to leave a little gap here because I've got a y major. So I'm going to be changing this guy over here on this side. Vertices, remember this always is dependent on your major. Okay, so we got a 0, 0, and then some stuff. Well, plus or minus 1, because it's my major distance. Foci are also along the major axis, but now my C is a square root of 26. And then my asymptotes, is that good enough? There. Asymptote, which would be y equals a 1/5 x, comma, y equals a negative 1/5 x. But we had already found that earlier. Those are my answers. Now, what does this graph look like? Well, y major, again, they have a transverse axis. They don't always ask for this. That's why I totally forget about it a lot of times. 2 times the major, 2 times the 1 is a 2. Okay, good enough. So my major is a 1. I'm only going up 1, and then I'm doing my hyperbola business here. My asymptotes are at 1/5, which is, not much slope there. Again, plus and minus. Okay. So I know that it does not really look like that. What it should actually technically more look like is something kind of like this here. Because, again, it should be riding close to that that asymptote as they keep going. So, ignore what I just did there. That's completely false. In fact, I don't like it so much that I'm going to try to erase it a little bit here. I'm sure there's a bigger way to erase it with my little program here, but whatever. I would ask if y'all have questions, but this is a recording, so, you're not going to be replying. If you do have questions, of course, you just ask me through the Ask My Teacher and all that kind of stuff on WebAssign, and I definitely will answer. I think that's it for that problem, so let's keep going. Got a couple more here. 113024. So x squared minus 3y squared is equal to, plus 48 is equal to 0. Now this is kind of weird. A lot of people would move the 48 over, but I kind of get a little weird with it. I move this stuff over here instead. So I got a 48 is equal to a negative x squared plus 4y squared. It's up to you. I'm going to rewrite this thing as a positive 3y squared minus x squared is equal to 48. So just kind of move them around to make them look pretty. Divide by the 48, of course. And so then I got 3 over the 48. Does this flip-flop like last time? No. Hold on right quick. I just want to verify something, okay? So 3 divided by 48 is 1/16. Yeah, that's how it works. So it's technically here a 16 in the bottom. I didn't write that down in my notes there, unfortunately. There we go. So now what do? I make sure that I have it as the major squared and minor squared. So the square root of 48. I'm sure that reduces. It's just not worth my time right now. Neither is it worth yours. If it's not perfect, let it go. So remember that this guy's the positive, so he's definitely the major. Notice that we have a y major this time, so that's cool. This is my minor. And so I can start, getting my other answers. C squared is major squared plus minor squared. So that would be the 16 plus the 48, 64. So then my C, when you square root the 64, you get 8. So that's kind of nice. Good to have there. So that's going to be your focus distance. I think they don't. That's it. They don't ask for the eccentricity. So asymptotes. Remember that it's going to be y equals plus or minus the y distance divided by the x distance. And these are, again, major minors. It just depends on the problem. So I have a y distance, and I have an x distance. That square root is included there. So this is my x distance. This is my y distance. Major, minor, but, it could be a major on the top. It could be a major on the bottom. It doesn't really matter. It's just y and x, because that's what slope is y over x. And so then in this particular case, 4 divided by the square root of 48, and then an x. And so these are going to be my asymptotes there. Again, I didn't even simplify because it's not worth your time. Final answers. Center is at 0, 0. Leave a gap. Vertices are always dependent on your majors. So then plus or minus, my major distance here was a 4. Foci are on the same axis as the majors, but it's a distance of c, which in this case was an 8. And then my asymptotes, as you know, you have to write them out lengthwise. So that would be 4 over the square root of 48x, then a negative 4 over the square root of 48x. They also ask for that transverse axis. Again, that's 2 times your major. Major is a 4. 2 times 4 happens to be an 8 in this case. Okay. Surely we're getting near the end. It's like so many of these things. 113027. So, I see. We're going backwards now. That's a relief. So we have this hyperbola doing something kind of like this here. Not perfectly drawn. Over here, that's at 3, and they give me this focus here at 5. Okay, so I have a focus of 5. That means my C distance is 5, but my major distance is a 3, and it's an X major. It's an X major. So I can already start setting it up. So x squared over major squared, y squared over minor squared. I don't know what minor is, but I do know that we're going to be equal to 1. The c is important because I got c squared plus major squared plus minor squared. And so I got 5 squared. Major's a 3 squared. And I got little m squared, solve for little m. So move this to the other side. I got 25 minus 9 is equal to m squared. If you do the math there, you get a 16. And so therefore, you get, well, I guess I could do it the long way just a second here. At 16. So m by itself is going to be a 4. That's my minor. Final answer then. My major again was a 3. My minor ended up being a 4. Again, that's still a negative, so it's not bigger technically, kind of, sort of. So there you go. Okay. Next one. 113032. This problem here gives you the asymptotes, and so I have this hyperbola. Again, it's not perfectly drawn, but you get the idea. Here's your asymptotes, which they'll be graphing for you. I'm starting over here at 5, and they say that my asymptotes are plus or minus 1/4 x. Now keep in mind, that's a 5. That's my major with a capital. My major equals 5. 5 distance. Cool. So it's an X major. My ending answer will be a positive X squared over 5 squared minus my Y squared over the minor squared equals 1. I mean, this is my answer. I just need to find what little m is now. Remember that this is a Y distance over an X distance. Okay? So I'm saying that my Y distance ends up being a 1, while my X distance is a 4. Okay? And that's not technically true because you can see that my X distance here is a 5, not a 4. But what I'm saying is that there's a ratio here. Okay? There's a ratio. I guess you can kind of set it up like similar ratios, I guess you could say. So my X, I'm sorry, it's Y over X. Y over X is my ratio. My slope was 1/4, Y over X. Over on this side, my y over x, my y distance, and my x distance, m over 5. So this is what I got for my asymptote. This is what I got for my equation. And this is just the format, you know. So these should be equal. They're the same somehow. There's a similar ratio. I'm going to multiply the 5 to the other side, and I got a minor of 5 over 4. And, like, that's your minor distance. We're basically done now. So x squared over, again, that was the 5 squared. And then my y squared, I have a 5 over 4 all squared. There you go. Cool. 113037. So they're going to throw different stuff at us all the time. Foci, they say, is at plus or minus 10, 0. And then my vertices are at plus or minus 6, 0. Something you should see immediately is that we have an x major. See how x's are my majors here? Again, you can say that's centered at 0, plus or minus some amount. So x major. I got a c is equal to 10, and my actual major, capital M, major, distance is a 6. You can see that from here and here. So that's good stuff. You can find your minor using these guys. C squared is equal to major squared plus minor squared. I'm just like thinking, how many times have I used this formula just in these past few videos? It's a lot. I just keep on doing the same formulas. I mean, I know that there's a lot to do on these problems, but there's not a lot new to do on these problems, okay? It might look a little overwhelming at first, but once you really get into it, it ends up not being that bad. This is a 64, so then square root of that is an 8. That's my minor. And so then putting it all together, here's my answer here. Positive x squared, because I had an x major, major of 6 distance, this case. And then I had my y, and my y distance, my minor was an 8. And there you go. Cool. Next one. 113046. They give me asymptotes of y equals plus or minus x. They say this is a hyperbola that passes through. This is a brand new kind of problem. 2, 3. They say, go, figure it out. What? This is like really not understanding anything. Well, they don't give you a lot at all. And that's why I'm going to start graphing it just because I don't know. Notice that this is a 1 right there. That's a 45-degree line, essentially. 1 over 1. So I'm drawing this as accurately as possible. 2, 3, 1, 2, 1, 2, 3 is about right there. That's my point. Now, I'm going to ask you, I'm going to have you think about this here. Is it an X major or a Y major? X major or Y major? You got your answer? It's a Y major because this guy right here is on the parabola. I'm sorry, the hyperbola. And I don't know exactly what's going on here. Again, it has to like cruise really close to this hyperbola, the asymptote stuff. But it probably looks a lot like this. Notice it's, when I draw it out, it's a Y major. Okay, it's a Y major. So therefore, I can already start setting up my answer kind of like this. Now, again, we're missing most of the components here. But my major, my minor, you know, now I have to keep going. But what I do have from this, if you notice, these are distances. This is my Y distance. This is my X distance. And that is important for my asymptotes. Because if you remember, that plus or minus 1x, that's going to be that Y distance over the X distance. Right? Well, so 1 is equal to my Y distance over my X distance. Again, I could just fill it in with the actual major minor, if you like. Okay? Now, what's interesting about this is that I'm trying to solve and figure stuff out. We'll move your minor to the other side. I'm saying that my major, the value, is the same as my minor value. Now, again, we're not saying bigger or smaller necessarily because we're going to have one as positives. Makes it obviously bigger, technically. But the value that we're going to get in the denominators there are going to be exactly the same for both of them. Okay, so we're going to have the same number twice. That actually kind of relieves my situation, actually. It helps me out a lot. Like, if you go back to what I do have, this guy right here, I can then say, well, I mean, they're the same numbers, so let's just use capital M, I guess, for both of them. I mean, it's the same numbers. I'm not saying they're both majors. I'm saying that they're both the same number, whatever that is. Well, look, they have a common denominator. See how I'm doing math now? All of a sudden? Move the m squared to the other side. And so I'm at this situation where I need to solve for m, that number. I mean, once I have this, then I'm basically done. What are my x's and y's? Well, they gave me a point. The 2, 3. So I can plug that in now. So 3 squared minus 2 squared is equal to my m squared, major and minor in this case. 9 minus 4, that's a 5. That's my m squared. So technically my major and my minor, again in this case they're both the same, is the square root of 5. And so I can go back to my final answer. Again, this was a y major, so he's going to go up front. He's going to go first. Then an x minor. Notice that there just happened to be the same number twice, and that is okay. Whew. One last question in this section, and it's an application question. I'm going to tell you I don't like this question. Just straight up, I don't like this question. I just find it super confusing. Super, super confusing. But I will do my best, and I'm going to just give it to you exactly how you're supposed to do it, okay? I'm just going to do it with you. Copy what I do. This is at a distance of 350. This is at negative 350. And there's this, like, I guess these are 2 sonar stations or something kind of like that, and there's like a boat out here, plane, something, I don't know. And they're saying that the signal, well, you get the idea. The signal has traveled at different times to both of these guys, and that's a 90 degrees right there, thankfully. So the signal from P travels from P to A. It is a 2640 microseconds. Milliseconds? Microseconds? I think micro is going to be like this guy, right? Micro minutes? Microseconds. Whatever. It honestly does not matter for this problem. And then P going to B, hold on. The signal from P to A is this much quicker before. It's that much before it hits B. So, like, it's going to hit A first, right? And then after this much more seconds, it's going to then hit the B. That's what's going on, okay? Whew. All right, whatever. They also say that my velocity of the signal is 980 feet per microsecond. That's my signal speed. And then they start asking questions. All right, first off, they say, well, what is the distance between PA minus the distance of PB and the absolute value of that? And I'm like, already lost about what are you asking? Well, I'm going to give you what it is very quickly. It's the 980 divided by 2 makes 490. That's what they're wanting in part A. If that made any sense to you, you tell me why. 'Cause there you go. They want to now find the equation of the hyperbola. Okay? And so it's a y major. So y is positive. I have my major. I have an X minor. So at least we got that much. Cool. Well, I'm going to tell you some things that we need to gain from all this. First off, to find your major, there's like a formula, I guess you can say. You're going to take that 490 that you got right there, and you're going to divide that one by 2 to make the 245, and therefore that's your major. Later on, we're going to need major squared, obviously right there. And so then you're going to square the 245 to make a 60025. Okay, so that's going to be important later. We're going to use that number right there. There's your answer for that one. Going back, apparently I got a 350 somewhere. I'm trying to find where I got that in my notes here. Is it from the microseconds? Oh, no. That was the distance right here. The 350, that distance right there. Okay, cool. Okay, so use that distance now from the actual picture. That's your C distance of 350. These guys are at the foci, apparently. These are at the foci. And so that distance there is your C equals 350. So, okay, we got that much. Okay, good. I was wondering where I got that. Now I got it. Well, we know that C squared is equal to major squared plus minor squared. Same old formulas. Nothing ever changes here. So again, this is going to be the 245 squared, minor squared. We're going to solve for it. Move this over to the other side, subtract them, and all that kind of stuff. I got a minor squared equal to 62475. Okay, cool. Again, it's squared. I didn't square root it on purpose just because. So going way back to the original what we need, this is my major squared, 0025. That was my major. My x is a minor, which would be the 62475 equals 1. That's their answer. That's how they're getting those numbers. That's your part B. Part C is now saying, okay, well, find the actual distance, P to A distance. I think they just put one horizontal line. So the distance between P and A directly. If you go back to the, I guess, picture here, we got an A, we got a P, and that's that distance we're looking for. B is way down here. There's a triangle, and it's right triangle and all that kind of good stuff. Well, we're going to just use this formula here because P is on the hyperbola, and they give me a Y value. Notice that my Y value here is 350, right? Like I know that my Y is equal to 350. And I'm just going to plug it into this guy. So 350 squared divided by 60025 minus x squared all over 62475 equals 1. And we're going to solve for x. X is that distance right here. Did not want to zoom in here. Well, that just looks weird now. Okay, there we go. That's my x distance right there. So x equals, and what did I get? I'm going to give it to you. I got 255 miles. And that's your part C. Okay, we did it. Thank you very much. Have a great day.